in my spare time, I'm really passionate about development, about virtual reality application, augmented reality application. You can follow me on Twitter and on my main website where there are all the web links about the blogs that I wrote. So let's talk about AR. Have you ever worked with augmented reality before? Raise your hand if you ever worked before. No? Okay, cool. So the definition that I like about augmented reality is this one from Google. That augmented reality is the things that brings everything with you on your screen, on your device screen. So it adds just computer-generated model on your smartphone, on your everyday object, on your everyday world. But okay, that's nice, but what is the status about augmented reality right now? What is the status about application, the most successful application in augmented reality? So they are mainly games, like you know, Pokemon Go, that is starting a new kind of experience in augmented reality, like using occlusion and so on. Or more modern games, like the one that Niantic developed for passionate about Harry Potter. And also there is Microsoft is developing the Minecraft AR game. Yeah, we can also state some other examples about augmented reality that can be used to change our sex in the picture or just augment our face. But it's probably not really useful in the everyday case. Google presented at this, in the last Google I/O, a sort of useful way to use augmented reality in your apps. Like, for example, extending the Google Map experience using some 3D model, like arrows and other, to help you to perform navigation using the screen of your device. Also, they presented a new way to extend the Google search using augmented reality. And so you can search for everything on Google. You can see the result of your search and also see in your real world the 3D model of them. And also they used for the Google I/O application a sort of augmented reality map for the venue. So you can see from your camera using the Google I/O application where the room are and so on. That's kind of useful. There are other applications in the market that are using augmented reality for real use cases that are not games, like IKEA Place, that allows you to put 3D model of their products, of IKEA products on the room that you are pointing with your camera. So you can test real measurement of their products. Or also eBay. eBay is using augmented reality in their application to help the user to choose the right package to send their product that they want to sell. So it's really easy to see if an object fits or not a package that you need to send. There is also a Google application about augmented reality using augmented reality for measurement. It is precise enough to give you some measurement in width and height that you can use to measure real object in the world. Yes, okay, but I was thinking probably measurement is a good tool in the travel company. So, for example, when you need to travel, you need to measure your luggage to check the allowance for the flights company, for example. And so during an hackathon in our company, the internal hackathon, I try to see if I could use augmented reality to check measurement in our application for your luggage. So I started to analyze the competitor. For example, now there is KLM, the aircraft company that's using augmented reality to help the user to overimpose a 3D model of the allowed luggage in the camera and check if the size is right. So it's just superimposing 3D model. There is also the EasyJet application that is doing kind of the same, but in the previous sample, the the user can drag the 3D model of the luggage through all the screen to check if it fits with the real one. In the EasyJet sample, the user moved the 3D object just moving the camera around the real world. There is also the kayak application that is some sort of smarter. It's smarter because it can scan the luggage. It can scan the sides of the luggage, so it understands the 3D environment better than the other application. It can realize the real measurement of the luggage. Also, there is the Ryanair application that is doing kind of the same of the kayak application. So the user just point the camera on their luggage, and after some seconds, the application understands if the luggage fits or not. But there's a problem. I tried to find this application for Android, and the Android application of this company has not augmented reality feature. Why not? Because this kind of application can be supported in Android, but they right now are iOS only. So I started to look for something to develop this using Android, in particular native Android using Java and Kotlin, and I found ARCore. So ARCore is the framework that Google created to develop AR augmented reality application. It has three main features. The one is motion tracking. So with ARCore, your software can understand the movement of your device in the 3D space. It has environmental understanding, so it can actually detect what is around your device. So in particular now is detecting plane, so vertical and horizontal planes, and so on, and feature points, but we will see later. And light estimation, that is another cool feature to represent 3D model on the real world, because it's a sort of estimation of the light, of the real light of your scene, so that the software, your application, can apply the same light feature, light characteristic on the texture of your model, so the model looks like more real. There is also this kind of feature of ARCore, there is augmented images. So using a preprocessed image, the ARCore can overimpose model on a 2D image that you decide. There is also cloud anchors. This is some sort of sharing between device, the 3D point that can be where a model can be placed. So it's useful to share the experience. And there is also augmented face, so you can develop your funny augmented face application. But this is not the case now. Again, we can develop this kind of app. With ARCore, you can use your favorite environment. So if you're coming from game development, you can use your favorite engine, like a real engine, like Unity. You can use JavaScript too, because ARCore is compatible also with Chrome. But coming from Android development, we are at droidCon now, so we can use Kotlin and Java in the same way to develop augmented reality application. The main sample app of ARCore is just one that is detecting a plane, or an horizontal or a vertical plane in your environment, and just place a 3D model of a droid on your plane, on your detected plane. And that is good enough to learn about ARCore, but you need to know that using ARCore is a little bit complex because it's based on OpenGL, so you need to learn how to develop with OpenGL with Android. It is kind of complex. There's a lot of think about the renderer, how to render a scene, how to render a 3D model, how to import one. But Google gave us a new tool, a new SDK to help us to develop on ARCore. This SDK is Sceneform. So what is Sceneform? It's just a 3D framework that make it easy to develop this kind of application on the top of ARCore. And it's based on three main features. So the high-level scene graph API. So we will see that building a scene is just simple like building a tree, composing each model like a node in the scene. Another useful feature that Sceneform has is a physical bezel rendered, that is provided by Filament, that is open source rendered by Google. This is just a really easy way to render the 3D model on the scene. And most important also, there is this an Android Studio plugin with Sceneform that is useful to create the 3D object, the 3D model, to view them, to edit them, and so on. So it's super easy. The plugin can be installed on Android Studio and can allow you to import the model like this droid. To integrate Sceneform and ARCore and to develop this with this in our application is very simple, because like we saw already, building the scene is just creating nodes and adding the nodes to the scene. So if you can see from the sample, I'm just creating to add a node to the scene. I'm just creating an anchor node. An anchor node, by the way, is a sort of node that can be anchored to a scene, so a 3D point that the software maintains in the time and space in the same point. So it's useful because if you are moving your device, the object will be there. Also, we'll create a rotating node, so it's a node that can be rotated. We can create a transformable node, that is a node that can be transformed, so moved or scaled or rotated enough. When you create a node, you can associate to the node a renderable. A renderable is just a 3D object that your 3D model that you want on the scene. So it's associated to the node, and like you can see in the last third line of the code, you just set the parent of this node, and this parent is the anchor. So I created the anchor, I created the node, and I attached the node to the scene. That's it. You can build with this node kind of logic all the synthetic environment that you want. So, like for example, there is the sample in GitHub from Google that is building the sun with all the planets that are going around. So let's start from the beginning. And I want to create something like our competitors are doing with just overimposing 3D model of our real luggage. So to integrate Sceneform and ARCore, I just need one line of code in our dependency in Gradle. So in this case, I'm telling, Gradle, give me all the dependency that I need to use the Sceneform, the AR fragment, and all that I need. I could also choose to only have dependency of Scene or ARCore on the other, but this kind is very generic, and this kind of dependency is very generic and can include everything that I need now. So in particular now there is the 1.10 version. In this slide we are using 10.9 version. Another useful things to take into account is that if we are building for SDK minor than 26 API, we need to ensure, that's because Sceneform is using constructs from Java 8, we need to ensure that we are adding this source compatibility with Java 8. We need to remind that in the manifest, we need the camera permission, and we need the Android AR feature in it. And we also need that, like we see in the last line of the manifest here, that the augmented reality feature is required. So the Play Store can decide if this application is compatible or not with your device. You can also say that this kind of feature is optional, so you can, in a sort of way, fall back and make compatible your app also with devices that are not supporting ARCore, that right now are really low. So to create your first augmented reality application after you decide and modify your Gradle and manifest, you just need to use the AR fragment. The AR fragment is coming from Sceneform, and it's just handling for you all the things about asking permission to the user, open the camera, show the camera on this fragment. So just add on the layout of the fragment and everything is done for you. Very simple. Like I said before, the main object of your development, if you want to place a 3D model on a point or 3D point that must not change throughout all the time and space, you just need to create an anchor. You just set the parent of the anchor to the scene, then you can create a node, associate the node to the anchor, and that's it. Another thing that is very useful is to associate an event to the fragment. So makes our 3D model interactive. Just add a listener to the fragment. The fragment is underneath for you. So in this case, we are using, set on top AR plan listener. So this listener will respond to all the tap event from the user, and for you will automatically translate the on-screen device coordinates to 3D coordinates, and you can do what you want with this. So like sort of try to intersect this coordinate to do something. What is a renderable? A renderable is just everything that you can draw on your 3D screen. And we have three kinds of renderables. We can have a standard Android view renderable. So it's a sort of 2D views in 3D, and you can use your layout XML file to render them. You can have a 3D object. You can, in this way, using downloading from remote a GLTF format, or you can just import with the Sceneform plugin in Android Studio. You can download and convert which model you want, even an animated one. And just to import this model and to use it in your code, you just have to call the builder of the model and just setting the source of this model. So I want, with the set source, create a builder, create this model taken from the source. Or you can use the shape factory. That is a sort of factory for three main shapes that are compatible with Android, with the Sceneform now. So three base shapes. Like in this sample, I used a cube that is modified to my needs. So just call the material factory, make a 3D object that is opaque with color. I choose the color, green, and then I just put the coordinate of the center and the dimension of the 3D object. So I have this one. Like I said, the shape factory has three different kind of shapes. So a sphere, a cube, and a cylinder that you can use. In case of the renderable layout, what I say, you can use your XML layout, the 2D one, and it will be rendered as a 3D object. So let's do it. We have the AR fragment. We know how to build a renderable. We take the fragment. We build our renderable, taking from remotely a 3D model that I have about the language. And a very important thing is the model renderable builder will return a completable future that is a Java construct that is asynchronous. So you need to handle this. You need to handle that. Okay, when the renderable will be ready, will be downloaded in a synchronous way, you can use it and assign to your variable, or you can handle your exception. Then I prepared some 2D renderables just to say, okay, this is the width of my luggage. So it's just a 2D banner of what I want to the screen. And I handle the event. So a fragment, when the user tap it on the screen, just take the point when the user tap, convert the coordinates from 2D space, the screen space, to 3D space, and just put an anchor on this coordinate with this renderable. That's it, like an Android sample. And I'm using a custom node right now. That is the one that is assigning to Andy. It's a draggable, routable node. What is it? It's just a node that can be dragged and rotated. I have not added the scalable one, because I don't want that the user can scale the measurement of the luggage. I mean, I'm just putting a 3D model with the size. I can use decides that I define it statically. And this node has to be initialized like this, so assigning the controller to the nodes. So this is the little video about the demo that I used in our application. So the user just selects his flights, and then after loading, oh, I have an error, but yeah, I can check the site. So the user opens the camera, makes ARCore detect some planes, tap on the screen, the 3D model of the luggage is there, the user can drag it, can rotate it. And like you see, the blue banner at the bottom and at the top are just 3D renderable from 2D layout XML. Very simple. But what if I want to scan the object? So like the two last apps that we checked out, the one from Kayak and the one from Sceneform, the one from Kayak and the one from Ryanair. We can do it? No. Only ARCore right now is compatible with some sort of 3D scanning of an object. ARCore is not compatible now. Yeah, we cannot do it. But what I was thinking, okay, but I want to achieve something similar. We can do it in some sort, adding some sort of AI in our application, some sort of detecting the shape of the luggage. Yeah, we can do it in a non-easy way using OpenCV. Have you ever worked with OpenCV before? Cool. There is a computer vision library that's, okay, you need to understand very well how to achieve this interpreting of the image and work on it with it. It's very complicated, can be very complicated. Or we can use TensorFlow, so using a sort of model, machine learning model that can detect for you if it's a luggage, what is the size of the luggage, very complicated too. But if I'm not knowing anything about AI, I mean, for me, AI can be just a set of if, like many are saying. Yeah, we can use Firebase. Firebase is it's an SDK from Google that offers you a lot of features. In particular, if we are using Firebase ML Kit, we can have many services like face detection, barcode detection, and so on, smart reply from your messages. And we also have a cool, simple app that is describing, a sample app that is describing to you all the new services, all the new features from ML Kit. And in particular, if you see the leftmost image on the screen, that is detecting for you an object. You can detect multiple objects, you can detect a simple prominent object. When I saw this image, I said, okay, probably I can use this kind of feature to make my augmented reality app smarter enough to resemble like the one that is scanning a 3D object. So using this feature, the object detection and tracking, this feature was presented in the last Google I/O, and it was about detecting statically in your device, so using a TensorFlow mobile inside, a TensorFlow mobile model that is running on your device, detecting an object pointed by the camera or multiple objects. And it also has some feature like a coarse classification, so it can understand what kind of object is that, what is the bigger set of the classification of your object that you are pointing. And it also, it is very important, it is optimized to run on the device. Because if you are developing for yourself some sort of algorithms to understand that and detect the object, it can be very complex to handle this kind of, the optimization, in particular of the battery. I saw in a talk yesterday that the main problem of using AI and ARCore on a smartphone is that the smartphone is going damnly hot. So, I tried to integrate Firebase ML Kit with ARCore. The first thing that I needed was that adding two new dependencies on my Gradle. So the last one is the one that I used for object detection model, so the very last one feature. And also I used the dependency for ML vision because I talked about, okay, I can detect the object from the camera, but I need some sort of classification that the one that is coming from the object detection feature is too coarse for me. So I passed the same to the same image to make it classified to the Firebase ML Vision. So to use the Firebase machine learning vision object detection, you just need to create a detector from the builder. And it's very important if I want to create an application that is doing detection of a streaming of the camera, I need to set the detector mode, as you can see the second line, to stream mode. You can also set this detector mode to a single mode when you can only detect the object from the static picture. So the important bit is create a builder, passing the configuration to the builder. It's like ARCore, it's like Sceneform. And then you need to create the instance of the detector. Simple enough. The detector needs to process image with the image that you are taking from your camera or from my input that I want. In my particular case, it was from ARCore. The detect image is outputting a task from Firebase, and this can be, and the response from this task can be handled by the listener. So in case of success, I take what is coming from the detection, that is a preview of the object detected in the picture, and the bounding box, that is very important, so the coordinates of the rectangle that is surrounding our object. And also I can handle the failure. So I created in the main activity a view model that is observing all the things that I am putting on the listener. So yeah, I detected an object from Firebase. I analyzed it. I took the preview. I took the preview image, so only the cutted image of the object. I took the bounding box. I passed it back to another Firebase service that is detecting for me the classification. So if it's a flower, if it's a dog, or if it's a luggage. And I call the search on it. So Firebase, for me, is detecting in a list of text the classification, the type of my object. So in an easy way, I can say, okay, is this list containing the word bag, baggage, luggage, there is under luggage, backpack, and so on? If yes, it means that I'm pointing to a luggage. So if I'm pointing to a luggage, I can associate in it a 3D object. I can create an anchor with ARCore and so on. So let's see how to do this. The most important part was to associate and synchronize what the input was from ARCore, so all the camera from the ARCore input, all the camera streaming, to the thread that was elaborating the Firebase detection. So what I did is creating the camera from ARCore was having a resolution of 6400 for 480. I created a graphic overlay that is an overlay that is a 2D layout on the camera that was allowing me to draw all the things. It's very easy. You can see in the source code. I will give you the link, but it's based on the Firebase sample, so it's very easy to draw on the top of the camera using the graphic overlay. And I used, like you can see in the scene add on update listener, this method is just saying, okay, given the scene from ARCore, update a listener calling this method. Update the listener calling this method. So every time that the scene is updated, I'm calling a thread, a bloody thread, because I'm coming from the sample from ML Kit, but you can call what you want, using a more performant threading way to do it. And yeah, you can just pass the scene to the listener. The thread is just getting the scene, is getting the frame from the scene, and using frame acquire camera image, is getting the image of the camera. In particular, we need to check if the format is right. So in this case, is UI UBU, and we need to convert the image in a sort of format that is good for ML Kit, to be processed to ML Kit. I use a utility function. Then we need to build the metadata to be used in ML Kit. In this case, we need the preview width and preview height of the image, so the dimension of the image. And we need also to say something about the rotation of the image. In particular, we have a value here that we are using, the rotation 19, because I was using the smartphone in portrait mode, and in portrait mode the camera it was in my device rotation 90, but you can create a smart function that is detecting for you the true rotation of the sensor. This is the rotation of the camera in particular, but it needs to be used to make ML Kit understand what kind of rotation of your images is. And then you can call your machine learning ML Kit processor to process that image with that metadata. And I was passing also the graphic overlay, that is the object that I said that it's allows you to draw on the top of the image. So it is just a frame layout with a canvas on it, you can draw it. What problem I had? Yeah, I had mixing the two libraries, ARCore, Sceneform, and ML Kit. I have this kind of integration problem. That in ARCore version 1.9.0, they added the class path of many libraries, not only this one. So I had conflicting error with independency that I solved with this bloody hell code in the Gradle. I hope that this will be fixed in the future. I checked with the last version, the ARCore 1.10, but it's still there, the error, but probably it will be fixed. And now I want to show you a demo of it. You can find, by the way, the code in my GitHub, but I can show you a demo about this application. So let's see. I have not my luggage with me, but I can use a bag. To calibrate ARCore, we need a floor that has many feature points. I don't think this floor is really good for it, but we will try. So yeah. We start the application. This is just like the application from ML Kit, but just modified to be integrated with ARCore. So I select that one. There is my... Okay, let's try to calibrate. Yeah, if you see the white dots, it means that the ARCore has identified a floor, and then I can put the reticle on it. So it identified that is a bag, in this particular case is a backpack, and it just put a 3D model on it. And the user can move the 3D model and can rotate it. Yeah, it's a little bit slow. But yeah, you can see that I can rotate with the rotate gesture, and I cannot scale it because it's not allowed to scale. And the good thing is that this object, this 3D object, has a fixed measure, so you can understand probably this will fit because this is the size of the allowance of my file company. It's okay, and I can use which 3D model I want. The good things of this application is that it's using also the new material design guidelines of for ML Kit for machine learning applications. So you can, for example, use a reticle, and the reticle is when it's perceiving an object, a 3D object, is creating a bounding box on it with some sort of design guidelines, and yeah, that's it. So the demo worked now. The next step of this project can be many. like one, it's using a proper TensorFlow model running on the device, because right now the Firebase object detection is running on the device, but the detection of the kind of classification of the object that is scanning is performing remotely. I can teach a machine learning model to understand that this is a luggage with data dimension, or it's an luggage, or so on. I can remove Firebase or use Firebase 2 to create a TensorFlow model using that's the last tool that Firebase gave us, using OpenCV, because I thought, okay, we can probably use OpenCV to identify the vertex of the shape of the luggage, but it's a very complex thing. Or maybe we can use a sort of 3D object machine learning 3D object detection machine learning model that can be very complicated, because I'm not an AI expert, but the 3D object recognition is very complex. Or we can wait for a feature in ARCore that is the 3D object scan. 3D object scan is something that is feature requested in their GitHub. It receives a lot of votes, and probably it will be implemented. I don't know, but we hope. Yeah, that's it. If you have any question, you can say it now, or you can find me on the social, on Twitter, and on my website. Don't do face detection, face augmented face application, but try to create useful augmented reality application. Yeah. Thank you.